Welcome to qnawire.
Hello students, in this question we have given this contingency table. Then by using that we have to determine whether the given data provide the sufficient evidence to indicate that the injection of antibodies affect the likelihood of the transfusion transmitted infections. That is, from the given information we can write the null hypothesis H0 is antibody and the infection classifications are independent versus the alternative hypothesis, which is denoted by HA, and that is antibody and infection classifications are dependent. So this is the alternative hypothesis. Now to test this hypothesis we are going to use the chi-square test of independence, and we know the formula for the chi-square test statistic is chi-square is equal to summation of observed frequency minus expected frequency bracket square divided by expected frequency. So suppose this is equation number 1, and now to calculate the value of test statistic, first we need to find the value of EI, that is the expected frequency, and the formula for the expected frequency EI is row total into column total divided by grand total. Now in the above contingency table, here we have already calculated the row totals and these are the column totals, and this is nothing but the grand total. So by using that we can compute the expected frequency. So for example, expected frequency, that is EI, for antibody and for infection, that is for the first observed frequency 5, antibody and infection, that is for the first row and first column. So now first row total is 82, first column total is 15. So 82 into 15 divided by grand total is 136. So we will get the expected frequency is approximately equal to 9.0441. Similarly, after calculating the remaining values of the expected frequencies, we will get these table for the expected frequencies. And now by using this we can compute the value of chi-square test statistic is observed frequency minus expected. So first observed frequency is 5 minus its corresponding expected frequency is 9.0441 bracket square divided by expected frequency, which is 9.0441, plus this is up to the last observation, which is 44 minus 48.0441 bracket square divided by 48.0441, and after simplifying this we will get the value of the test statistic is 5.1189, that is approximately equal to 5.12. Then the degrees of freedom for the given test is r minus 1 into c minus 1, where r is the total number of rows and c is the number of columns. So here we can see that there are 2 rows and 2 columns. So this is equal to 2 minus 1 into 2 minus 1. Therefore the degrees of freedoms are 1. And also we have given the significance level alpha is equal to 0.05. So by using the chi-square distribution table we will get the required p-value at the test statistic 5.12 is 0.0237. Now we know that according to the decision rule, when the p-value is less than the significance level, then we reject the null hypothesis, that is H0. So here, since this p-value is less than alpha is equal to 0.05, therefore we can reject the null hypothesis, that is H0, and hence we can conclude that the antibody and the infection classifications are dependent. So I hope you find this video useful. Thank you.